This video, let us see the second method of Lagrange linear equation called method of multiplier. Next is method of multiplier. Here solution is obtained by choosing a multiplier, whether it is a constant or a function of x, y, z. Here it is represented as LMN, multiplier LMN, such a way that LP plus MQ plus NR is addition equal to 0. Choose LMN such a way that this addition tend to 0. That is, we know that auxiliary equation is what? dx by p equal to dy by q equal to dz by r. So, if LMN or multiplier, then multiply the first ratio, multiply and divide the first ratio by L, second ratio by M, third ratio by N, then add the corresponding numerator and denominator. We will get one equal ratio. This is the equal ratio. LDX plus MDY plus NDZ divided by LP plus MQ plus NR. But the condition for choosing an multiplier LMN is what? LP plus MQ plus NR equal to 0. Therefore, the denominator tend to 0. So we can equate the numerator to 0. So from this we can get one simple differential equation LDX plus NDY plus MD LDX plus this is MDY. LDX plus MDY plus NDZ equal to 0. Let us see few problems in method of multiplier. The first question, solve 3z minus 4y into p plus 4x minus 2z into q equal to 2y minus 3. Okay. Let us see the solution now. First check whether the given equation is Lagrange. Yes, this is Lagrange equation. Where capital P. What is capital P here? 3z minus 4y and q 4x minus 2z, then or 2y minus 3x. Then to solve Lagrange equation, write the auxiliary equation. Here the auxiliary equation is dx by capital P, dy by capital Q, dz by capital R. That is dx by capital P is 3z minus 4y, dy 4x minus 2z, and dz by 2y minus 3x. But here method of grouping fails since the separation of the variable x, y, z from the ratio is very difficult. So we are going to apply method of multiplier. Let us take 2, 3, 4 as a multiplier. It's like a trial and error method. Okay. I'm taking 2, 3, 4 as a multiplier. To say 2, 3, 4 as a multiplier must satisfy the condition LP plus MQ plus NR equal to 0. I'm going to check it now whether it satisfies the condition. So multiply the first ratio by 2. Multiply and divide the second ratio by 3. So the numerator is 3 dy now plus 4 dz. Corresponding denominator 2 into 3z minus first ratio by denominator by 2, multiply the denominator of the first ratio by 2. So 2 into 3, 6z minus 8y, then multiply by 3, 12x minus 3 into 2, 6z, then multiply by 4, the last ratio, so 8y minus 12x. Now check whether it 10 to 0, 12x and x getting cancelled, 8y with minus 8y getting cancelled. Okay, 6z plus 6z getting cancelled. Okay, so from this you can say 2 dx plus 3 dy plus 4 dz equal to 0. Okay, that is on integration. We can give the solution. So what is integrating this? What is the integral of this? Integrating, get 2x plus 3y plus 4z equal to some constant c. So this is nothing but the first part of the solution. Use 2x plus 3y plus 4z. To find the second part, we need another multiplier. I'm taking one variable multiplier now. Let us take x, y, z as a multiplier. Okay. Now we have to check whether it satisfies the condition of multiplier or not. What is the condition for multiplier? Multiply the numerator by x, y, second ratio, third ratio by z. Divide the denominator, okay, multiply the denominator. So by x, y, z. So x into the first denominator, 3xz minus 4xy. And second by y. So 4xy minus 2xz. Okay, then third one by z. So 2zy minus what was 3xz. Now look at this, all the terms in the denominator getting cancelled. Okay, this getting cancelled, and 4xy and minus 4xy is also getting cancelled. So from this we are getting the relation x dx plus y dy plus ez dz equal to 0. On integration, it's a simple differential equation. On integration, we can give the solution. So what is integral of this? Integrating this, okay, integrating what is it? X square by 2 plus y square by 2 plus z square by 2 equal to some constant c2. So we can write it in terms of the constant x square plus y square plus z square equal to some 2c2, that is c2 dash. So what is the second part of the solution we here? X square plus y square plus z square. Okay. Therefore, the final solution of the given equation is f of 2x plus 3y plus 4z, comma, x square plus y square plus z square equal to 0. Okay, the next question. Second one, solve x square y minus z into 3 plus y square z minus x into q equal to z square x minus 4. Okay, now let us see the solution. This is a Lagrange equation. It is in the form of Lagrange. Equation, the form P capital P plus Q capital Q equal to R What is PQR here? P is nothing but x square y minus z. Then Q y square into z minus x. Then R is here z square into x minus y. Then write the auxiliary equation. What is auxiliary equation? Dx by x square y minus z. Then dy by q. That is y square z minus x. Then dz by z square x minus y. Further, to solve this auxiliary equation, we are going to apply method of multiplier. Since method of grouping fails here, it's very difficult to separate the variables from the ratio. So I'm going to use method of multiplier. So we have to choose certain multipliers like trial and error methods. I'm going to take some multiplier now. First I'm taking 1 by x square, 1 by y square, 1 by z square as a multiplier. Okay. Let's check whether it's a multiplier or not now. Okay, I'm taking this as the multiplier. What is the condition for a multiplier? If it is a multiplier, then that LP plus MQ plus NR should be 0. Okay, let us check the condition now. Here, multiply by 1 by x square, first ratio. 1 by y square by the second ratio. Okay, third ratio by 1 by z square into dz. See the denominator here. Corresponding denominator. Multiply the first ratio by 1 by x square. Okay, 1 by x square. Here we are having x square into y minus z. Correct? So that x square getting cancelled. Same way the second ratio. 1 by y square into z minus x. Okay. Then plus 1 by z square into x minus 4. Then what happened here? This is z square getting cancelled. Y square getting cancelled. What about this x square and x square? So see the remaining inside the bracket y minus z minus x plus 1. While adding it 10 to 0. Okay. So from this we can say, 1 by x square dx plus 1 by y square dy. Yeah. Plus 1 by z square dz equal to 0. Now integrating. What is the integral of this? We need integral of this function. Integral of 1 by x square dx plus integral of 1 by y square dy plus integral of 1 by z square dz equal to some constant c1. Okay, first constant c1. And what is 1 by x square? It's nothing but integral x power minus 2 dx. What is integral x power minus 2 dx? It's nothing but x power minus 3 by minus 1. So plus 1, no? Minus 1 divided by minus 1. That is, we can write this as minus 1 by x, correct? So minus 1 by x, minus 1 by y, minus 1 by z equal to some constant c1. Or we can write multiply 4 by negative plus 1 by y plus 1 by z equal to some c1 dash negative of this. Okay. This is first part of the solution. We can say it is u. Same way, we have to find one another solution, second part of the problem, by taking some multiplier. So let us assume here 1 by x, 1 by y, 1 by z is the next set of multiplier. 1 by y, 1 by z. Take this as multiplier. 1 by x, 1 by y, 1 by z. So we can now let us check whether it satisfies the condition of multiplier or not. 1 by x dx plus 1 by y dy plus 1 by z dz. divided by, see the corresponding denominator, multiply the first ratio by 1 by x, denominator by 1 by x, will reduce to x into y minus z. 1 is getting cancelled, x getting cancelled. Same way, second ratio, y into z minus x. Third ratio here, z into x minus 2. Okay, so now look at this here, all the terms getting cancelled. Okay, y term with the xy, zx and the x is that positive term here. Then same way, y is and minus y is getting cancelled. So we can say 1 by dx, 1 by y dy plus 1 by z dz equal to 0. Yeah. What is the integral of it? It's nothing but log x plus log y plus log z equal to some log constant log c1, c2. Okay. Integrating. Okay, then we can write it as log of productive, logarithmic product of logarithm, log c2. So here log getting cancelled. Second part v is nothing but x, y, z equal to c2, right? So from this we can write the solution as the form 1 by x plus 1 by y plus 1 by z, comma x, y, z equal to 0. Let us see one more question. The third one, solve x into y minus z p plus here y into z minus x into q equals down z into x minus y. Okay, now let us see the solution. To solve this equation, first identify what is capital PQR of Lagrange equation. X into y minus z, nothing but p. Q is here, y into z minus x and z into x minus y. Then write auxiliary equation. Here the auxiliary equation is dx by capital P, that is x into y minus z, and next is dy by capital Q, y into z minus x. Okay. Then dz by capital R, z into x minus y. Okay. Then to find the solution, we are going to apply method of multiplier. So let us assume, let us take here 1 by x, 1 by y, 1 by z as one of its multiplier. Now let us check whether it is a multiplier or not. What's the condition for multiplier? LP by LP plus MQ plus NR should be 0. So multiply the first ratio by 1 by x, numerator of the second ratio by 1 by y dy, then third ratio by 1 by z. So 1 by z is divided by, multiply the denominator with the first denominator of the first ratio with 1 by x, x is getting cancelled, it's only with y by z now. Multiply the second ratio denominator by 1 by y, y getting cancelled, we have z minus x. Then z getting cancelled in the third ratio, so z x minus 1. So all the, see the denominator, all getting cancelled at 10 to 0. Okay, so from this we can say 1 by x dx plus 1 by y dy plus 1 by z dz equal to 0. So integrating On integration, we can get the solution here. In integration, integral dx by x is log x plus log y plus log s equal to some constant, that is log c1. So by product rule, we can write x, y, z as c1. This is the part of the solution in here. In your integration. Integrating. So, okay, next we need one. Okay, you got part of the solution x, y, z. Then to find the next part, we need one more solution. So to find the next solution, let us assume one more multiplier. I think 1, as it is add, we can get 0 in the denominator. So let us take 1, 1, 1 as the multiplier. Let us just add as it is dx plus dy plus dz numerator. Corresponding denominator is, what is the denominator here? Multiply as it is, add as it is, xy minus xz first term. Second term is yz minus yx. Third term is here plus xz minus xy. Sorry, zx minus zy. So it's getting cancelled. All the terms getting cancelled there. Okay. So what is now? From this we can write dx plus dy plus dz equal to 0. On integration, we can give the solution. So integrate. Integrating. What is integral? Integral dx x. Integral dy y. Integral dz is equal to some constant c2. Therefore, the solution is the solution. What is the solution now? Solution is f of x u comma v. Here u is nothing but x, y, z. And the second equation solution. Second part is x plus y plus z equal to 0. This is the solution of the given equation.